Number 2 is about transition metal chemistry. This one you have done in practical chemistry, where you test for iron 3 and also iron 2. Iron 2 in the presence of hydroxide is reddish brown, sorry, it's dirty green. This is iron 3 hydroxide, so it's a red-brown precipitate. There's the iron 3 hydroxide, iron 3 plus OH minus. When you do the LCM of the charges, the 3 and the 1, you realize that the LCM tells you it's just 3. Therefore, I need 1 of the iron 3, I need 3 of the hydroxide, because 3 times minus 1 give you minus 3 to balance out the plus 3 charge. All this is valid as a result of lowest common multiple, something you have done in primary school, I hope. Okay, you got to describe what is observed in this reaction. So do you know the color of iron as a solid? And do you know the color of copper as a solid? And do you know that this is a transition metal solution, is aqueous? It has got color as well. And mind you, the color of the solution is not the same as the color of the solid, okay? Same with this, but then you need to be careful. Fe2 plus aqueous versus FeOH twice solid. This is a dirty green PPT. This is in water, no OH minus. A lot of people are confused about this, okay? So this is not a precipitate, this is a solution, and its color is not going to be dirty green, okay? It's actually very pale green solution, yeah? But in the presence of this solution, which is blue, it will go to like very pale green solution, okay? So you might not have learned this, but you will have used it at some point, yeah? The redox reaction of iron 2 to iron 3 with the purple color manganate 7, yeah? You might have done that in practical chemistry, so you have done it indirectly, I guess. So the pale blue solution, of copper 2 plus aqueous fades away or gets lighter, becomes lighter to pale green of copper 2 plus. What else? The iron solid used becomes used up, will disappear, will decrease in size, I guess, because it will get used up. I don't want to say used up because, you know, I might not know what is in excess and what is limiting, yeah? The iron solid use will decrease in size, okay? And pink, because that's the color of copper, yeah? It's kind of like very light pink, a light shade of pink. Pink copper solid starts to form. So I mentioned about the solid, I mentioned about the solution. I think there's nothing more I can say here really, okay? So, I mean, 2 observations, including color changes and stuff, they should give me my 2 marks, I hope. All right, so you got to use this equation to explain oxidation has taken place. I hope you've done OLRIC as your acronym, where oxidation is loss of electrons. There's also, in terms of oxidation number, which if I'm not mistaken, it's already been taken out in all-level syllabus, but teachers continues to teach oxidation in terms of increase in oxidation number. They say use this equation, but they did not specify you have to use this in terms of electrons or in terms of oxidation number. As long as it's correct chemistry, because they did not specify you have to use electrons, you can of course use oxidation number. If you apply it correctly, I'm sure you will get the marks because it's correct chemistry. The people who are marking the paper will have done chemistry. They know oxidation number, okay? Alright, unless the question specifically say in terms of electron, okay? So I'm going to use the oxidation involving loss of electron first. You want oxidation, right? So if I write the half equation, that is Fe2 plus 2 electrons. The iron loses electron, okay? Therefore, iron gets oxidized. Oxidation is loss of electron. Or the iron increases in oxidation number from 0 in Fe, very important to specify from what in what, yeah? To +2 in Fe2 plus. This is oxidation. So either explanation would do, really. Okay? Now use this equation. Oh, they want the reduction now. So the Cu2 plus 2 electrons give you copper. Cu2 plus gain electrons. Therefore, Cu2 plus gets reduced, or Cu2 plus is reduced. Or I can say the copper decreases in oxidation number from +2 in the ion, which is Cu2 plus. That means the oxidation number of an ion is just the charge of the ion itself, to 0 in copper. This is reduction. So overall, it's a redox reaction because you involve, when you add these two half equations together, you get this complete equation, which is a combination of oxidation and reduction, which give you redox reaction. Next bit is about electrolysis, and you have molten. So these are your cations, and these are your anions. Well, I mean, there are two of it, but anyway. Cations. Cations are positively charged. Cations will go to the cathode because they are attracted to the cathode. Therefore, cathode is negatively charged. What happened at the cathode? Reduction happened at the cathode, red cat. Okay, what is reduction? Reduction involves gaining of electron at the cathode, which is negatively charged, where cations are attracted to. Okay, I hope you can see the logic. So the negative electrode is going to be cathode. So they're trying to confuse you, unless you know what you're talking about, because you know the ions are attracted to something which is oppositely charged, right? So if this is positive, why would cation which are positively charged go there? All right, when you think about it, yeah? So once I label it, I know what exactly is going on. These are half equation. Gain of electrons on the left, and then I'll get the magnesium metal, because that's the whole point of the electrolysis. I want to get magnesium from there. I have to balance the atom, and I have to balance the charge by gaining electron, because this is reduction, because this is at the cathode, which is negative electron, etc., etc. Yeah. What happened to the chloride? The chloride is going to give you chlorine gas at the anode, and it will involve loss of electron, because oxidation is loss of electron. Oxidation happens at the anode, which is positive electrode, because anions, which is negatively charged, are attracted to the anode, which is positively charged. Okay, now this thing is not balanced because I need 2 chlorine, and actually that's why I get 2 times -1. That's why I need 2 electrons there. All right, I've done the equation a lot of time in my life as a chemist, so I know exactly what I was talking about. So that's why I have the 2 electrons before I even balance the equation. Once you get the hang of it, it will become a natural thing for you to do, even as a student. Yeah. Oxidation number, you gotta use oxidation number. So I am not sure if you guys are still doing oxidation number, but regardless, if you are not taught oxidation number in school, I would really encourage you to look up what is meant by oxidation number and how to calculate it. It will save you a lot of time, and it will save you a lot of trouble when you get to A level. In this question, for example, the magnesium there is magnesium 0. I do bracket 0. That means the oxidation state of magnesium is 0 in magnesium solid, because this is an element, it's a metal. The oxidation state of a substance in its elemental state is going to be 0, just like this copper will be copper 0. This is an ion. An ion is single ion, which means the oxidation state is going to be the charge of the ion. Just like the magnesium here, the charge of the ion is +2. That's why the oxidation state of the ion is +2. All right. Which one is reduced? Reduction is also defined as a decrease in oxidation number. So decrease, going from +2 to 0 is a decrease. So copper 2 plus is reduced. Okay, or you can say copper 2 plus aqueous is reduced. All right. So the oxidation number of copper decreases. So the oxidation number is of that particular atom, but it decreases from, you gotta specify from what to what. The +2 is in copper 2 plus, from the value in the species to 0 in copper. Okay, so yeah, therefore it's a reduction. What you could also appreciate is, how can you get from +2 to 0? you have to gain electron. Gaining of electron is reduction. So you could have used in terms of gaining of electron as well. So copper 2 plus must gain 2 electrons to form copper, and gain of electron is reduction. When you think about what happened at the electrolysis above, reduction happened at cathode, reduction involved gaining of electron. This is reduction. Reduction involved gaining of electron. So the plus 2 will gain 2 electrons, plus 2 will gain 2 electrons, and you become zero oxidation state. Zero oxidation state there. Alright? Next bit. You know magnesium doesn't react with cold water, but magnesium reacts with steam. And they want you to name. They want products. So there's actually more than one product. You see? It's already given in the question itself. It's a plural. So what happened really is, I would know the equation, because this is a O-level case study. Steam is H2O gas. Therefore, you gotta get the stat symbol correctly, because it's a steam, not water. Water will be H2O liquid. You form MgO. And does it form MgO? Let me think. Oh yeah, it forms MgO, and it will give off H2. Alright, so there's a solid and there's a gas. Magnesium, one magnesium, no problem. Okay, 2 hydrogen, no problem. 1 oxygen, no problem. But they do not want balance equation. Okay, what do they want? They want the name of the product. This is called magnesium oxide. And you also have hydrogen gas. Alright, now calcium reacts with water, okay, because the outermost electrons are less tightly held. So what happens is, when calcium reacts with water, it will not form the oxide, because this is with steam, okay, and you also have water here, whereas here is steam, which is not water, okay. So what you're going to get is, instead of the oxide, this is what you're going to get. They don't need stat symbol, because they didn't say stat symbol. They didn't say balance equation, but whatever equation you write in chemistry, if you don't balance it, that's it. End of story, okay? You won't get anything, alright? It will form calcium hydroxide. Calcium hydroxide is Ca2 plus OH minus. You have a 2 plus, you have a minus 1. To balance out the thing, you need 2 of it. That's why I need 2 of it. Okay, these are in your area where you start to learn chemical formula, and how to get the correct chemical formula is very, very important. And you give off hydrogen gas as well. So balancing the equation, 1 calcium, no problem, yeah? Unless you get the formula wrong, then you have a problem. H2, there's 1 oxygen, but there is 2 oxygen, because these are bracket, right? So it's this 1 times 2, that's 2 oxygen. So I need a 2 there to get 2 times 1, which is 2 oxygen. Hydrogen, there are 4. Hydrogen, there are 2, so 1 times 2. 2 plus 2, so I just need a 1 there. That's fine, alright? Involve oxidation. So if you have iron SO4, so the iron SO4 is iron 2 sulfate. Do you see that? So automatically is iron plus 2. Iron plus 2 in iron SO4. What does it become? It becomes iron 3 oxide. You are lucky that they actually give you the name. So it's iron 3 automatically. Increases in oxidation number to iron plus 3 in Fe2O3. So I'm aware that in O level there are some school, or rather the syllabus might not have covered in terms of oxidation number. So if there is another way of doing it, you can think about it involved the iron plus 2 going to iron plus 3. You can think about it as loss of electrons. So also, you know that oxidation is loss of electron, oil rig. So you can also, this is an alternative answer, not an additional answer. Also, you can say iron plus 2 in FeSO4 loses electron to form iron plus 3 in Fe2O3. Realistically speaking, I still think oxidation number is the best way of answering it. And if you do put that down as an answer, there is no way you will get penalized because they did not specify it that you should discuss it in terms of loss or gain of electrons. They just simply say, basically, why does it involve oxidation? They did not say do not use this. They did not say use that or use this. And correct chemistry will never be penalized. Okay? Next bit there, how does this reaction involve oxidation? So this is copper plus 2. Look at the charge there. Okay. I there is iodide, so this is iodine minus 1. This is also iodine minus 1. Therefore, it's copper plus 1. This is a molecule of iodine, so this is iodine 0. Okay, so how does it involve oxidation? So here to here, this has an increase in oxidation number. While I'm aware that oxidation number might not be specifically covered in O-level, but I still think that it's an important concept to have been covered in O-level. And if you had used oxidation number in this question because they did not specify using like gain or loss of electron, using specific concept, they did not specify that you cannot use anything else. And oxidation number is a perfectly valid chemistry concept that if you had shown you know it and it's correct and you can show it's oxidation, then you know how in the world are they going to penalize you? Yeah, okay, because they did not specify in the question at all. Okay, so you can also think about oil rig. So oxidation is loss of electron. So you go from -1 to 0, so you must have lost electron. You must have given away the electron. That's why you lost the negative and you increase the oxidation number. They're all related really, okay? So the iodine increases in oxidation number from iodine -1 in I minus to iodine 0 in I2. Okay. Next bit, identify oxidizing agent. So this is redox. Phosphorus as an element is going to be phosphorus 0. Copper as an element is copper 0. Copper as an ion is +2 because the charge of the ion is +2. This is slightly tricky. This is going to be phosphorus plus 4 times -2 because oxygen is bonded to the phosphorus, so it's -2 there. Overall charge is -3. Phosphorus is -3 plus 8, so it's +5. Hydrogen here is +1. Hydrogen here is +1 because oxygen is -2. Overall is 0 as well. So the hydrogen and oxygen does not change oxidation number. Oxygen is still -2, hydrogen is still +1. Okay. Oxidizing agent. So you know what an oxidizing agent does, right? So oxidizing agent oxidizes the other substance and its surface is reduced. So we are looking for a species which is reduced, and you can tell that is reduced. That is decrease in oxidation number, that is reduction. So the oxidizing agent is copper 2 plus because copper 2 plus has been reduced from +2 in Cu2 plus to 0 in Cu. Either you say that, or you could say copper 2 plus has oxidized phosphorus, from 0 in P to +5 in PO4 minus. They both, PO4 minus. They both are saying the same thing because of the definition of oxidizing agent, yeah?